Good morning, everyone. I am Rowena D.R.D. Cardi. So our topic for today is solving exponential and logarithmic equation. So, introduction. There are two basic strategies for solving exponential or logarithmic equations. The first is based on the one-to-one properties of the second is based on the inverse property. For a is greater than 0 and a is not equal to 1, for the following properties are true for all x and y for which log a x and log a y are defined. So, one-to-one properties ax is equal to ay if and only if x is equal to y. So, in inverse property, a log a x is equal to x, or log a to the power of x is equal to x. So, for example, our original equation here is 2 to the power of x is equal to 32. So, rewrite the equation to substitute the number. So, 2 to the power of x is equal to 25. The solution is x is equal to 5 and the property is 1-to-1. Then the letter B, log 4x is minus log 8 is equal to 0. So rewrite the equation log 4 x is equal to log 8. So the solution is x is equal to 8. So 1-to-1 pa rin. So let's go to the inverse. Sa letter E, a is equal to e to the power of x is equal to 7. So rewrite the equation in x to the power of x. E to the power of x is equal to in 7. So our solution here is x is equal to in 7. So this is very simple to solve this because you only use a calculator. So our property here is inverse. So that's it. And the other example, inverse. So the strategies used in example 1 are summarized as follows. So here, example 1, the strategies that used to summarize that is strategies for solving exponential and logarithmic functions. So we have 3. So number 1, we write the original equation in a form that allows the use of one-to-one properties of exponential or logarithmic functions. Number 2, rewrite an exponential equation in logarithmic form and apply the inverse property of logarithmic functions. And number 3, rewrite the logarithmic equation in exponential form and apply the inverse property of exponential function. So, here, solving logarithmic function. So, to solve a logarithmic equation, you can write it in exponential form. So, in x is equal to 3. So, remember that equation in x is equal to 3 is the logarithmic form. And e to the power of in x is equal to e to the power e cubed. So exponentiate each side. And x is equal to e to the power of 3 is the exponential form. So we have logarithmic form, which is in x is equal to 3, and our exponentiate each side e to the power of n in ln ba na or in? Hindi ko sure. The x is equal to e cube. So our exponential form is x is equal to e cube. So this procedure is called exponentiating each side of equation. It is applied after a logarithmic expression has been isolated. Another example, solving logarithmic equation. So, solve each logarithmic equation. Here, we have problem A. In 3x is equal to 2. So, the solution for that is in 3x is equal to 2. Rewrite the original equation. And for our exponentiate each side is e to the power of in 3x is equal to e squared. So that is our exponentiate each side. And to form the inverse property, so simply write 3x is equal to e squared. And x is equal to 1 over 3e squared multiplied each side by 1/3. Then after that, use the calculator so that you can get the answer of this. Yeah. Then the solution is x is equal to 1/3 e squared. So after multiply each side by 1 over 3, so approximately 2.46. The solution is x is equal to 1/3 a squared and approximately 2.46. So check the original equation. So next, for letter B, log 3, the quantity of 5x minus 1 is equal to log 3, the quantity of x plus 7. So rewrite the original equation. So to 1-to-1 property, simply write 5x minus 1 is equal to x plus 7. So to solve for x, so x is equal to 2. The solution is x is equal to 2. This is the original equation. So solving logarithmic equation, because of the domain of logarithmic function generally does not include all real numbers, you should be sure to check for extraneous solution of logarithmic equation. So prove example 10, the change of base formula. So prove the change of base formula log a log bx over log ba. So solution, begin by letting y is equal to log a to the power of log ax. So, and writing the equivalent exponential form, so we simply write a to the power of y is equal to x. So solution. So now taking the logarithms with base b of each side, produces the following. So here, log BA to the power of y is equal to log BX. So y log b 8 is equal to log bx. So power property. So next we write a is equal to log bx over log ba. So divide each side by log ba. So log ax is equal to log bx over log ba. So replace with log ax. So if you have noticed, for y is equal to log bx over log ba, for the replace with log ax, so may mo na siyang log ax is equal to log bx over log ba. Same naman de. No, it's a joke. So that's it for the logarithmic equation.